Hello everyone. Welcome to today's webinar on cooling tower shutdowns and startups. Over the next few minutes, we will discuss the issues and good practices related to stops and starts. In short, the good practices to respect in order to effectively protect all the components of your cooling system. In a perfect world, cooling systems would continuously operate with no stoppages. Ideally, the exposed water surfaces would always be in contact with flowing water, which would make protecting the metal surfaces and controlling microbiological growth much easier. Unfortunately, this is not the case, as most comfort cooling systems operate seasonally and will undergo winterization, where equipment is emptied and the systems can be left with sections that are partially submerged with stagnant water. Intermittent stoppages for maintenance are also common during certain portions of the cooling season. Even cooling towers used in industrial processes will have intermittent stoppages, usually due to production disruptions. These are obviously much shorter than seasonal stoppages, but will still affect the water quality and impact the system's protection. The technical challenge is to maintain the proper conditions throughout the phase. Some preventative measures can reduce the inconvenience associated with cooling system stoppages. However, it's often difficult to plan these as it's dependent on our ever-changing weather. These spontaneous stoppages prevent the proper removal of debris, thus allowing the debris to build up in different areas of the system. It's also important to consider that seasonal cooling towers, when stopped, are often only partially emptied. Some surfaces remain in humid environment whilst others submerge in stagnant water. This interface zone becomes very highly prone to corrosion. Finally, the submerged areas are stagnant with conditions that become ideal for microbiological growth and under-deposit corrosion. As previously mentioned, some stoppages are not always seasonal, as some occur for maintenance. Even if the stoppage is planned, water quality and system protection can be impacted. For example, some systems have significant water losses as the system is designed for overflow. This creates a water quality imbalance during startup that can affect corrosion protection as well as biocide injection. If the stoppage is longer than 2 to 3 days, the stagnant water will increase the risk of microbiological growth as it is the perfect condition for bacterial proliferation. Unfortunately, we cannot plan intermittent stoppages for low heat loads as they depend on the system's requirements as well as the outside temperature. It's difficult to prevent problems associated with these interruptions. In these situations, the disadvantages will be the same as those as unscheduled stops for maintenance. Partial or total stoppage of the system, water loss due to overflow, water quality imbalance, treatment program imbalance, partial or total stagnation of the water in the system. Systems with redundant equipment components such as chillers or heat exchangers will inherently have partial system stoppages for an undetermined period. These operating conditions can result in stagnant water in just a portion of the cooling system. And again, this will offer a perfect setting for bacteria such as Legionella to grow. These environments are very similar to the evaporative condensers as well, where their irregular operation will allow for the basin water to stagnate with no biocide treatment for days. When the system starts up again, sometimes with no warning, the complete system can become contaminated. No matter what the reason is for cooling water stoppage, maintaining the adequate water quality can be difficult. Usually, there will be water loss due to overflow as discussed, and because the inhibitor is sometimes controlled to the bleed water meter, the inhibitor is no longer fed to the system properly, causing the inhibitor protection to be ineffective. The overflow of water will result in chemically imbalanced system. With no water circulation, biocide injections might also be interrupted, which could result in an uneven distribution since the isolated zones will be dependent on the treatment. Water quality imbalance is also an issue with seasonal or sudden stoppages. These typical problems are, with no water circulation, there's a potential for silt and debris to settle in the system. In some instances, the side stream filtration also stops. Corrosion is accelerated due to insufficient inhibitor. Other problems might arise with the circulation dynamics as the buildup of biofilm and Legionella growth. By interrupting the biocide injections, health risk also may arise. Stagnation fosters biological growth, so even partial stoppages become an important risk. By interrupting the biocide injections, health risks may also arise. Stagnation fosters biological growth, so even partial stoppages become an important risk. The stagnant areas can rapidly become areas of bacterial growth, and we know that bacterial and Legionella proliferation creates a high risk for those in proximity during startup. The problems highlighted are common and bring about numerous consequences that could affect your system's performance in terms of the lifespan of your equipment and piping, and especially the safety of the people near the system. Preventative measures should be applied before stopping the system. The first step usually occurs a few days before the stoppage, where bleed rates must be increased. This will reduce the water salinity and lower the amount of debris and silt that could settle. For example, normal conductivity would be around 1200, should be lowered down to 500. Once the deconcentration has been carried out, one day before the stoppage, it is recommended to add a biodispersant as well as a non-oxidizing biocide to preventatively disinfect. Note that biocides such as bromine, chlorine, as well as glutaraldehyde are the ones that should be avoided during the storage period. 6 to 8 hours after adding the biocide and biodispersant, a volatile inhibitor treatment should be applied to create a lasting protection on all the surfaces. This treatment will effectively protect all surfaces, even the humid and submerged areas. This is also a perfect time for carrying out complete mechanical clean of your cooling tower. If this is not done when the stoppage occurs, it must be completely done during startup, as it will eliminate any accumulated debris that needs to be removed from the water basin, the sprinklers, the fill, and the mist eliminator. Cooling tower startups also require a fair share of preventative measures. For example, if a mechanical clean was not completed at the stoppage, it must be done before the startup. The injection system and controller should be verified, cleaned, and calibrated. If you have a filtration system, it should also be inspected. The filter media must be analyzed, disinfected, or even replaced, as it could become a major source of bacterial proliferation. Once the system is restarted, it is important to disinfect with an oxidant, such as chlorine or bromine. Stagnant water left over in the system may have biofilm, which must be removed before startup, as it can become a location for Legionella to grow. Once the cooling tower is operating, treatment conditions must be reestablished quickly and maintained throughout the warm season. Please keep in mind, evaporation rates will be lower in the first few weeks, which means that the treatment dosage rates must be adjusted accordingly. This table demonstrates the ratio of Legionella counts in terms of cooling towers that were proactively and preventatively disinfected versus towers that were not disinfected. You see that in the towers not disinfected, there's a significant increase in the Legionella concentration as measured by qPCR. When a system is temporarily stopped for 1 to 2 weeks or longer, there are guidelines to follow. Prior to the stoppage, it is important to adjust the bleed to reduce the concentration of silt and debris. A scheduled outage is the best time to perform mechanical clean and preventative disinfection using halogen-based chemistry. This is also a good opportunity to inspect the different components of the system to detect any potential problems and complete preventative maintenance on the chemical injection system, the conductivity controller, the online probes, the analyzers, and side stream filtration unit. Short stoppages may seem harmless, but preventative steps must still be taken as soon as there is a potential of stagnant water due to the risk of bacteria proliferation. A rule of thumb for stoppages of 2 days or less, there should be no problem as long as the biocide is injected before the stoppage. When the outage is longer than 2 days, it is recommended to inject biocides on regular intervals as required and ensure that it is dispersed throughout the entire system. It's important that the recirculation pumps be restarted during the injection of the biocide to maintain circulation and to ensure an even concentration throughout the system. The same applies for partial system stoppages. Example, for repairs, where the water in the area becomes stagnant, must be treated regularly to prevent excessive proliferation. Example, swapping recirculation pumps will cause water stagnation and promote bacterial growth. As you can see, regardless of the length of the stoppage, as well as startups, cooling towers are a challenge. Preventative measures must be effectively understood, managed, and carried out. There are many benefits to applying the correct measures in stops and starts, such as better equipment performance and protection, better microbial growth, and improved health and safety. To ensure a safe and effective cooling tower startup, a proper game plan must be established. This game plan must include specific interventions such as the initial steps to be taken before shutting down the equipment, adjusting the water quality based on the situation, the preventative cleaning of the cooling tower and its components, the preventative disinfection of the entire system on a regular basis. For each stage discussed, Magnus has all the detailed procedures available for you. We hope that this information was beneficial for you. If you have any questions or comments, please do not hesitate to communicate with your Magnus rep or email us at info@magnus.ca and we will answer you in the shortest of delays. Thank you very much for your time.